Good day, guys. Welcome to the channel, and this session is about vertical projectiles. Now, the question says a man throws ball A downwards with a speed of 2 meters per second from the edge of a window 45 meters above a dam of water. 1 second later, he then throws a second ball B downwards and observes that both balls strike the surface of the water at the same time. Now, you have two balls. You release ball A second later you release ball B, but they hit the surface at the same time. Calculate the speed with which ball A hits the surface of the water. Okay, now first things first, you must assume direction. Okay, now in this question I'm going to assume downwards as positive. That is the first assumption I'm going to make. Okay, now secondly, you create what we call data. What is data? Data, you write down what is given. Okay, I am given v initial for ball A, which is equals to 2 meters per second. Okay, I'm also given delta y, or height, which is equals to 45 meters, and then this is always given gravity, or A, which is 9,8 meters per second. Okay, now all these are given, but this VF is unknown. That's what we are looking for. In the as a velocity of ball A. Okay, now we are going to check. This is what do you have? We have a building, okay, with a window there. Then yeah, you are just here, and the height of this is 45 meters. Now calculate. Okay, you throw it from this point. Now calculate the speed of which this ball hits this point, the surface of the water. Now the formula that is feed is that formula that says sorry, it's the formula that says VF squared is equals to VI squared plus 2a delta y. We are using delta y because we are dealing with a vertical motion, not the horizontal motion, so we're not going to use delta x. Okay, now v initial is given for ball A, which is 2 squared plus 2 from the formula into 9,8 for A, into height, which is 45. Okay, now you are going to have 886, but remember this is the value of VF squared, so you need to put a square root and a square root. Now VF is equals to something like 29,77 meters per second. Okay, now that's you answering the first question. Calculate the speed with which ball A hits the surface of the water. Now we have a second question where they say calculate the time it takes for ball B to hit the surface of the water. Okay, now So now the formula that we can use here, we can use that formula that says I'm sorry, okay, we can use that okay, let me stop this. Okay, let me see what it says. Okay, let me post it. Okay, now we have a VF which is equals to VI plus A delta T. Okay, now you got this formula from the back of your question paper. As it is, you'll get a mark for writing it, including the other formula you wrote there. Okay, now you already know final velocity of object A. Okay, so what you're going to do, substituting final velocity of ball A, you are going to have 29,77 from the previous question. Okay, those are sevens. And the initial velocity it's 2 because it was thrown at the speed of 2 plus 9,8 delta t. Now 29,77 minus 2 will give you 27,77, which is equals to 9,8 t. Now you divide by 9,8 both sides, your t will be equals to 2,83 seconds. Okay, now but guys, this is the time it takes for ball A to hit the surface, because we've used the final velocity of ball A, initial velocity of ball A. So this is the data, this is time for ball A. Okay, this is time for ball A. Now time for ball B, we were told that ball B was thrown 1 second later. Now time for ball B is equals to 2,83 seconds minus 1, which is equals to 1,83 seconds. Okay, now that is time it takes for ball B to actually hit the surface of the water. Okay, now calculate the initial velocity of ball B. Okay, so we are asked now to calculate the initial velocity of ball B. V initial of ball B, we are going to use delta y, which is equals to, I hope you guys can see, let me write a little bit below. Okay, it's delta y, which is equals to V initial delta t plus 1 over 2 a delta t. Okay, now what is the initial velocity? That's what we are looking for. What is the height? We were told that the height is 45 meters. Okay, we even used it here on the first question. Now the height is 45. V initial, it's unknown, but the time we know that it's 1,83 seconds plus 1 over 2 into 9,8 into seconds. Now I'm going to transpose. Okay, and I think on this formula there's a squared here, guys. Forgive me for my mistake. Even here there will be a squared. Okay, so now you are going to take this part alone, transpose. Transpose meaning bring it to this side of the equal sign. Now it's going to be 45 minus that part divided by 1,83. Okay, then you will later find out that your V initial is equals to 1,5 15,56 meters per second. Now this is initial for ball B. Okay, so now it makes sense why the two balls hit the surface at the same time. This was thrown at the higher velocity. Now the next question says, on the same set of axes, sketch a velocity versus time graph for the motion of balls A and B. Clearly indicate the following on your graph. You must indicate initial velocities for both ball A and B, time of release for ball B, the time takes by both balls to hit the surface of the water. Okay, two initial velocities, this and that. Okay, now let us draw the graph, and this is a very important skill that you need, guys. Okay, now drawing the graph, you obviously need the title, velocity time graph. You need to show that you are drawing a velocity versus time graph between ball A and ball B. This is your title. Okay, for the motion of balls A and B. Okay, then after writing that title, you now draw something like this. Okay, this is your initial point. Now they asked you to show initial velocities for both ball A and B. Okay, so your initial velocities for ball A will be 2, then initial velocity for the other one is 15 comma something, so it's 15,56, somewhere there. Okay, now also the time it takes for the release of ball B. So after 1 second, ball B was released. Okay, and then the time it takes for both balls to hit the surface of the water. Okay, then you're going to have somewhere there, maybe 2,83. Now this will be something like that. Okay, then 1 second later, ball B was released here, something like that. Now this is the time it takes for both balls to hit the surface of the water. So your graph needs to end there. Okay, this is just a junk. Is there an eraser here? I'm not sure if there is. Okay, it's my first time using this function. Okay, now those are your full 5 marks. 1, 2, the release of ball B, 3, 4, and the correct shapes. Make sure that they are parallel to each other. Why? Because the slope of this ball represents the gravitational acceleration. The slope of this ball also represents the gravitational acceleration, and gravitational acceleration is the same, meaning that the two gradients are the same, so they should relatively look the same when it comes to gradient, so they should be parallel. Okay, now let's solve another question. Okay, now take few seconds to read through the scenario here. solve the problem, then unpause so that we can solve it together. Okay. Now, a ball is dropped from the top of a building 20 meters high. Ignore the effect of air resistance. Define the term free fall. Okay, that is the first question. Now, second question, 3.2, calculate the speed at which the ball hits the ground. 3.2.2, time it takes the ball to reach the ground. Then lastly, you have to draw the graph. Guys, drawing of graphs is very important, and interpretation of graphs. In other questions, you're going to get a question in the form of a graph. Okay. Now, let's see. I can define from here. So free fall, we are talking about motion of an object. We are talking about motion of an object. This is an ECT, object under the influence of gravity alone, or you can say force of gravity alone. Okay, so motion of an object under the influence of gravity alone, that is definition of a free fall. Now calculate the speed at which the ball hits the ground. That is the second question we have. Now, what did I say? Start by determining your data. What do you have as your data? What do you have? You have V initial. Why? They said a ball is dropped. When you see the word dropped or the word released, if you see the word dropped or the word released, they mean V initial is equals to 0 meters per second. Okay. Now you also have delta y, which is your height, as 20 meters. Okay. You also have your gravity, which is 9.8 meters. By the way, take downwards as positive. Okay, that's what I assume. You can assume the other way around. You can assume upwards as positive. It's up to you. But if you assume upward as positive, then gravitational acceleration will be a negative value, because it is always 9.8 meters per square second downwards. Okay, now final velocity of which it hits the ground with, Vf is equals to unknown. That's what we should be calculating. Okay, now let me move, and now we can start with our calculation. Okay, the speed at which the ball hits the ground. Now, since we are looking for Vf, we can use this formula of Vf is equals to Vi squared, that is Vf squared, okay, plus 2a delta y. Mark for writing that one. Okay, now V initial is given as 0 squared. You get a mark for correct substitution. Don't write 0, we know 0 squared is 0. Don't write 0, write it as 0 squared into 2 into 9.8 into height, which is 20. Okay, now we are going to have the value of 392, but that value is for VF squared, not VF. So you take square root of both sides. Now your VF is equals to 19,80 meters per second downwards. Okay, now calculate the time it takes the ball to reach the ground. Okay, now the time it takes for the ball to reach the ground, you can use the formula of VF is equals to VI plus A delta T. Okay, now we are looking for time. We have acceleration, we have initial velocity, it was given as 0. We have final velocity, we calculated it. So final velocity is 19,8, which is equals to 0 plus 9,8 t. So now you divide by 9,8 both sides. 9,8 both sides. Now t is equals to 2,02 seconds. Okay, now we are done with this one. Now they say sketch a velocity time graph for the motion of the ball. Okay, and they say no values required. If you want, don't show the values. Alright guys, take note of the values if you want, but we don't necessarily need them. Okay, now velocity time graph, here we are going to have V in meters per second. It's a must for you guys to label your axis, guys. Okay, then this is 0. So since it was dropped, it has to start from 0. That one you have to show it. And this is time, this is t in seconds. Okay, no need to show any values. So but for just accuracy's sake, this is 2.02 seconds, but no need for any value. Full marks before that value is entered. Okay, now this is your question. I hope it has cleared some confusion. Now let's go to the next one. Okay, now we have an interesting situation. Okay, a ball A is thrown vertically upwards from a height h, unknown height, with a speed of 15 meters per second. Okay, initial speed of ball A given. Alright, let me do this and write data immediately. Data A for ball A, so VI is equals to 15. Now which direction do I take as positive? Let me take downwards as positive, so that means this is negative 15. Okay, let's read further. At the same time, the second identical ball B is dropped. Now data B, this is for ball B. V initial is also given, which is equals to 0. Why? Because there's a dropped from the same height as ball A as shown in the diagram below. This is thrown up, this is dropped. Both balls undergo free fall and eventually hit the ground. Explain the term free fall. I defined it from the previous problem, so I'm going to skip it for now. Now calculate the time it takes for ball A to return to its starting point. Okay, this is an interesting part, guys. Okay, now for ball A to go to the maximum height and coming back to its starting point, there are a few things that you might know, or you need to know instead. Okay, so I'm going to use this formula of a VF is equals to VI plus A delta T. Okay, a mark for that. Now, what is the V final? V final for ball A is 15. V initial is equals to 50. Okay, but a negative 50. Okay, there's an equal sign here. There's a negative 15. It's not negative negative, it's just negative 15 plus 9,8 multiplied by time, what we are looking for. So what's happening here, when a ball is thrown from a certain height and it comes back to that particular height, time taken for the ball, I mean the speed from here to maximum height, it is the same speed of which it returns to the same point with. That one you just have to know it. It happens like that. I hope you guys understand what I'm saying. If you throw a ball with 15 meters per second upwards, it is going to return to the same point with the same speed. Okay? But in the opposite direction. I hope that one you understand it. Now, another thing that you might need to understand is the issue of time. Time that it takes for a ball to leave its starting point to maximum height, and from the maximum height to where it starts is the same, meaning that from here to maximum height it's half of the time taken from here back to its starting point. Makes sense, ne? So you're gonna see everything throughout the calculations. Now let's continue. When you transpose this 15 to the other side, it becomes positive. So 15 plus 15 is equals to 30 into 9,8 times t. Okay, now you divide by 9,8 both sides, it just has to be more than 3, obviously, which is equals to 3,06 seconds. That is the time taken for this ball to go to the maximum height, come back to where it started. Okay, now calculate the distance between ball A and ball B when ball A is at its maximum height. So I just explained, when ball A is at its maximum height, the time is half of the time you have here. Why? Because I said time from here to here is the same as time from here back here. So time taken from here to upwards, the same time taken from upwards back to the same point. Keep that one in mind. Now let's calculate how far ball A went up there. Okay, now we are going to use let me try to go down there. Okay, because there's enough space there. Okay, now we are going to use the formula of delta y, which is equals to v initial delta t plus 1 over 2 at squared. Okay, now do we know the height? That's what we're looking for. Okay, do we know the time? Yes. Initial velocity? Yes. Everything else we know it. So initial velocity, because I took downwards as positive, it's going to be minus 50. Okay, direction is very important, guys. Remember, velocity is a vector quantity. There's both magnitude and direction. Okay, so half of this, it's 1,53, because half of 6 is 3. 1,53 plus 1 over 2 into 9,8. This one is positive because it goes down to the direction of the assumed arrow. Okay, 1,53 squared. Now you calculate everything else, punch it into the calculator. You're going to have a negative, this is not a squared, ne? It's a half from the upwards equation. So it's a negative 11,48 meters. Why is it negative? Because ball A moves in the upward motion. Okay, that is the reason. Now that is where ball A is. Now delta YB, how far is ball B now? With the same time, VI delta T plus 1 over 2 AT squared. Okay, now initial velocity, it's 0 multiplied by time 1,53 plus 1 over 2 into 9,8 into, okay, close bracket, open, 1,53, close it again, squared. Okay, now okay, when you punch everything else, this is 0, then this will give you something different. Okay, when you punch it into the calculator, you will realize that YB is equals to 11,47 meters. It's positive because it's going downwards. Now if you want the distance, so YAB, the distance between ball A and B, is equals to the addition of the two. Okay, now how addition? You will take YB minus this one, which will be positive. Now it will be 11,47 minus 11,48 meters, which is equals to 22,95 meters. Okay, that is the distance apart. Now draw your graph. Okay, let me clear. Yes, so with the two previous two examples, I've stated the rules, the title and other things that you need to draw. Okay, and remember I assume downwards is positive, so my graph will look like this. Okay, this is my 0 point. I don't know why it's behaving like this. Okay guys, now here I'll be having minus 15 as a starting point, then here I will be having 15, then it will move from here to somewhere. Okay, so then it's like this. Okay, this is time it takes to return to its starting point. This is the maximum height, so the maximum height is 1,53. This is 3,06, and then this is time in seconds, and then this side is velocity in meters per second. Okay, now it's 4 marks. There's a show initial velocity, it's here. This one they didn't ask about it, but I showed it. The time it takes to reach its maximum height, they want this time, it's a mark. It's a mark for that mark. The time it takes to return to its starting point, this time they want it. Then overall the shape and the fact that you able to exist, it's a mark. So those are the 4 marks. Okay guys, let me clear the page. Okay guys, now this is what I call a bonus question. Okay, so pause, sit down and solve this question. Okay, those who are attending my session, please bring it up to my sessions, then we can solve the question together. All right, and anyone who's attending the YouTube channel, just solve it and test your physical science skills. Okay, thanks for watching the video. Please like, subscribe and share to your friends. Cheers guys.